Hello, everybody, and welcome to another episode of Grade 10 Mathematics done by the Road to A initiative done by Rotaract Club of NSBM. Welcome, I'm Janet Surya, your teacher, your lecturer on Grade 10 Mathematics. And last time, uh, we were doing about fractions. So we did halfway, and the other halfway is today. The other half is today. So we'll move on to it. And first of all, before moving on to the chapter, let's do the 2018 and 2019 sums. So because we know the theories, and we can brush it up first, and then I'll go back into last time's theory again and brush it up again and get it going and in the fractions chapter today. So hope you guys are doing fine. And yes, this is Road to A Plus initiative by Rotaract Club of NSBM. Let's get on with it. Okay, let me share my screen. So moving on to the 2018 paper. Moving on to the 2018 paper. Yes, this is the 2018 paper. Awesome. So 2018 paper, we have, let's see how many sums are there for fractions. Just fractions. Because I said last time also that fractions is more of a way to do sums, more of a help doing big sums. So this is actually, this is what is going to help you to do big sums. Not this is not going to be tested directly, but this will be tested in your first term examination. Like in 2018, they have asked, like in the part A of paper one, they can ask you one question, one or two questions around it. Yeah, here's the first question. I think this is related to fractions. Let's get on with it. So they have asked, what they have asked is simplify 1 over x plus 2 over 3x. 1 over x plus 2 over 3. Simplify and find the answer. So what is the answer? What we can now, you should remember that the first thing you should see is the fact that the denominators are different. So when the denominators are different, I said you can't add or subtract. You can do the other stuff. The multiplication, division can happen, but addition and subtraction according to Bodmer's rule and all those. The first principle I taught last week was you should keep your denominator the same. This is the first principle I taught last week. So that's what I said. Again, back to our concept, the model of answering a question in mathematics. If you are a person who's watching this video for the first time, if you're watching Grade 10 Mathematics, this is the first video you're watching of Grade 10 Mathematics. Please go to the perimeter chapter and check. We have talked about a concept, a model called model where you can answer any question related to mathematics in grade 10 and grade 11, basically all levels. So where we're telling that if you know what the question asks, if you know the data given by the question, and if you know the concept behind the theory or the theory behind it, definitely when you figure the three dots out, you can figure out what is the answer. So here we told that the denominator should be equal always to add or subtract. So here we should make this. What has happened is one denominator is 3 times the other denominator. So we can't divide this. Better we make this whole thing multiplied by 3. When it multiplies by 3, the denominator and the numerator both will multiply by 3. So then the answer will be, then the simplification will happen 3 over, because we multiply the whole thing by 3. Then the simplification will go to 3 over 3x. Am I correct? Like if you cut this 3, like if you divide this by 3 again, that will give you 1 over x. That's just the multiplication by 3. So that whole fraction, just the whole fraction, The others will remain the same, 2 over 3x. Now, you see the denominators are the same. As the denominators are the same, you can straight away simplify it without any uh, any problem or anything. You can straight away simplify it. So basically, what was the theory tested here? This theory, if you can remember last time I told, the first theory I told was make your denominators the same. So here we have made the denominators the same, and we have simplified it. We have added it. Even in subtraction, same theory applies. You need to have the same denominator. Now are we moving on to the next sum? I'm pretty sure there's another sum. Yes, here you go. So how are we going to do this? Just imagine, I actually remember last time I gave you guys homework. Not homework per se, kind of I said to do the exercises. So we'll move on to that. But first, I'm going to give you the confidence that you can answer. Even now, you can answer the 2018 to the 19 first term examination. So you are ready with fractions. Just the fact that there's small parts to be covered, like to give you more practice, I will be doing those. But now we did one question, we got done with it. And now we're moving on to the second. It says x over 2 minus 1 equals 1. So solve this. They're saying solve this. So how are we going to solve this? X over 2 minus 1 over 1. So the denominator, yeah, so the denominator should be the same. The denominator of both should be same. Like when it comes to a fraction, the denominator should be same. So in any fraction, when it's a whole number, let's say it's just 5, the fraction is also 5 over 1. Do you get it? Like 5 divided by 1 will give you 5. So basically, each and every whole number will have a fraction like this. So here also it's 1 over 1. We can represent this whole thing as 1 over 1, 1 over 1, even whole numbers. So x over 2 minus 1 over 1. Now we have to make the denominators the same. There are two methods to do this, okay? This is the first method, which I've never ever used this, but I'm going to say it like I have to show it. X over 2 minus, I multiply both of these by 2. Minus 2 over 2, like when you cut this is 1. And this is also 2 over 2. Like divided by 2, then it will give you 1. So you just have multiplied both of these by 2. Then x minus 2 will be equal to 2. Okay. Straight away you can get x minus 2 equal to 2. Then x equals 4. That's one way of doing it, but I really prefer another way. The x should be equal to 4. Let's see if my answer is correct. I might be wrong. Let's see. So moving on, the second method, number 2. This method, I'm telling you, use this method. This method is very, very easy. When x over 2 minus 1 equals 1, first of all, keep the fraction on one side. Always try to make the fraction alone. Keep it alone. Then take minus 1 to the other side. How are we going to do that? X over 2 will equal to 1 plus 1, 1 plus 1, which will be equal to 2. Now x over 2 will be equal to 2. You don't have to write it like that. You can straight away write x over 2 equals 2. Then 2, this is a division, right? So we are going to take it up, multiply it. 2 into 2, you will get 4. You have taken this to the other side. When you take the division of a fraction to the opposite side of the equation, it gets multiplied. So 2 into 2 will give you 4. Same answer, two methods, same answer, but I prefer the second option. So please, like you can go with your own way, but the second option will cost you lesser time. So I believe that is better. Now we'll move on then. 19 sum 20, those are very, very not that's all. Yeah, Okay, there's a big sum. I didn't know that. Okay, there's a big sum. Awesome. So last time we learned about application of fractions, like application in real life of fractions. So this is a question in part B. Yeah, I am a bit wrong. I'm sorry about that. In part A, they will ask those two questions kind of way. In the first term exam, this is only happening in the first term examination. I'm so sure that it won't happen in all of us. So that's why I'm saying those two sums we did were easy. 15 we did, and we did 8, which were very easy. Uh, and then moving on to the first question of part B, which is also a fraction from a stock of clothing materials, which it's a more application based sum, where it says from a stock of clothing material which were brought to sew shirts and shorts. 307 was used to sew shirts. What fraction of the stock is remaining after sewing the shirts? 1/4 of the remaining is used to sew shorts. From a stock of clothing which were brought to sew shirts. 37. So what is the fraction? Okay. A stock. A stock was bought. A whole stock. The whole stock considered as one. It is 1 unit. Okay. The whole stock is 1 unit. This is what the question asks. What the question asks is what fraction of the stock is remaining after sewing the shirt. So they have bought 1 unit to sew both shirts and shorts. So what happens is 3/7 has been used to sew shirts. That means remaining, which means what fraction of the stock is remaining after sewing shirts. That means there was 1 unit, and out of that 3/7 has been used. Hence 7, hence 1 minus 3/7, because 1 from 1 unit, 3/7 has been used to sew shirts. Yeah, stock is remain. What is the remaining after sewing shirt? 1 minus 3/7. What is the answer? How to simplify this? Always remember to make your denominator the same. Then you multiply it by 7. Multiply the whole thing by 7. 7 minus 3 will give you 4. 4/7 will be your answer. What fraction of the whole stock is used to sew shirts? But remember, there's a 1/4 of the remaining is used to sew shirts. 1/4 of the remaining. So out of the whole stock, 3/7 out of the whole stock, out of all 1 unit, 3/7 was used to sew shirts. And the other part, there is a remaining of 4/7. Now we found that remaining 4/7. Out of the 4/7, 1/4 of the, they say 1/4 of the remaining is used to sew shirts. Always when they say 1/4 of, remember 1/4 of කියලා කිව්වහම write it down. 1/4 of remaining of remaining na 4/7 of කියන්නේ we learned that of is multiplication in bottomless is another term for multiplication in bottomless. 4/7. So 4 to 4 gets cancelled. The answer will be 1/7. What fraction of the whole stock is remaining after sewing the shirts and the shorts? So what fraction of the whole stock is remaining? So what we have done, if you see again the second question of that part, the second part of that question, 1/4 of the they have said 1/4 of the remaining is used to sew shirts. So 1/4 of the remaining is 4/7. So 1/4 of 4/7 will give you the answer here. 1/4 of, we know from bottomless, of means multiplication again. another term for multiplication kind of way. So 1/4 into 4/7, which will give you 1/7. So now the total we can see, the denominators are the same. The total we have used up is 4/7. 4/7 gives shirts the stock again. 1/7 has gone to shorts. So that's 5/7. So what fraction of the whole stock is remaining after sewing the shirts and the shorts? What is the remaining after all this is done? That means 5/7 විතරයි අපිට කියේ. කියන්නේ 4/7 ගියා shirts වලට, shorts වලට ගියා 1/7. Those two එකතු කරාම 5/7. Remaining will be 1 minus 5/7, the total. So that means it has to make a 1/1. So we can denominator equal karana. There is also always a denominator to any whole number. Then equalize the denominator by multiplying by 7. 7 minus 5 will give you how much? 2. 2/7. If you add this up, 5 plus 2, 7/7, that will give you the whole unit. If the remaining stock of materials is 6 meters, find the length of the total. Find the total length of the material bought. If the remaining of the material is 6 meters. Now this is a scholarship song. Because they are saying, if the remaining stock of material, remaining stock stock remainder 2/7 is 6 meters. Find the length of the whole total, find the total length of the material bought. That means 1/7. You can remember when Nimal buys 3 pens for this amount, how much can Nimal buy for this amount? You can remember how we do the direct proportion method. So 2/7 will give you 6 meters. 1/7 will give you 1/7, meaning this has been divided by 2, will give you 3 meters. Hence 7/7, which is the total, will give you 7/7. 1/7 again 2. When you find when something is given, always find it to the smallest unit. When you find it to the smallest unit, that is 1/7. When you know the value of the single unit, you can multiply straight away by the total amount, that is 7 here in this case, which will give you 3 into 7. 3 into 7 is how much? So this will give you 21, yeah? 21 meters. If 1 meter of the material, so like it's straight away sum from direct proportions kind of way. It's a sum you did in your not all of us, your scholarship exams. 2/7 is 6 meters, 1/7 is 3 meters, and 7/7 will give you 21 meters. If 1 meter of the material costs 200 rupees, find the value of the stock of clothing material bought. If 1 meter of the material cost is 200, they say 1 meter is 200. Find the value of the stock of clothing material bought. They are saying find the value of the stock of clothing, that is the full unit, the full whole unit. Find again 1 meter at this year now 21. Now they have given the unit price, the unit amount. So that is 1 meter is 200. So 21 meters is multiplied by 21. That is 4,200. That is 4,200 rupees. Those two questions you can see are very the direct proportion method questions, which are very, very simple. So this exactly is what fractions is. We have learned. We did very few sums. If you can remember, last time we did very few sums. We learned the concepts, we learned the theories. Now we are applying it, and we can even do the exam papers. So that's why I always say there is always a model. Yeah. So now we know that there are 2 questions in part A of paper 1, which are small questions, which will be asked to simplify basically. And there will be a big question in part B in your first term examination asking about the application of fractions. Here we have done that question. And then now we'll move on to 2019. Okay. Hope you guys understood it. This is the end of 2018 paper, fraction sum. That was really a nice sum. I really loved it because if you know that feeling when you do a sum, that is the okay. We'll move on then. Clear all my drawings, and I will share the 2019 paper. Okay. The first question again, yes, you can see this is the 2019 first term examination of the Western Province examination actually. So simplify again, they have given a very similar sum to 2018 again. As I told you, the models are the same. So this is very, you know, if you know your models, if this is going to be asked here, and if you know your concepts, and if you know if you have practiced a bit, and if you know the concept of what the question asks and what are the stuff in the questions, you can finish this very easily. So what are the stuff here? They have said we have to make the denominator the same. The denominator is not equal. Then you have to make the denominator the same. So how to make the denominator? I'm going to be faster here because I explained it very well last time. So I'm going to be a bit faster and I will show you exactly what are the steps we are going to write. Straight away we are going to write. We are going to multiply this whole thing by 4 times. Why? Because this denominator is 4x. That means this is a single x. So this should be multiplied by 4 times, which will give you 4 over 4x minus 3 over 4x. 4 minus 3 will give you 1 over 4x. This is your answer. The end. It's a very simple one. Just make the denominators the same and do the addition or the subtraction. That's for addition and subtraction only this happens. For multiplication and division, this is not considered. And that's the end of that. Moving on to the next question. Yeah, we did this, and then there should be another question. Definitely. Yes, 10th question. Here we go. This states that if you can see, it's the same kind of model which was in the 2018 paper. If you have done these 2 papers, you know that this is going to come. So you are getting ready for that. You're getting ready for a paper. So we are going to use the second method, but I will show the first method also again after doing the second method. We should always keep the fraction alone and take this. Minus becomes plus when it is taken to the other side of the equation. So 6 is the answer. 5 plus 1 will give you 6. This will be cross multiplied. Then the answer will be 12. The first method is the longer method will be making the denominators the same, where x over 2 minus 2 over 2 equals 10 over 2. We have multiplied these two. We have multiplied this and this by 2. So now we'll move now all the denominators are the same. So the answer will be x minus 2 equals 10 straight away, because the denominators get cut off here. X minus 2 over 2, it becomes 10 over 2. That means 2 get cancelled off. These get cancelled off. So x equals 12 again. And that's how you do that question again. Don't use the first method, use the second method. The second method meaning the first thing we showed by that in the 2018 paper, I showed this as the second method. That's why I said second method. Now we'll move on to the next question. Next question should be the bigger question. Let's see where it is. Yes, there's an application again. This is what I'm saying. The model is there. If you have done your past papers, better than your exercise book. If you've done your past papers, my friend, you are gonna get very good marks. So moving on to to this question, part B, first question. A tailor used 2/5 of a fabric roll to sew tablecloths, and 3/4 of the remaining were used to sew pillow covers. What fraction of the whole fabric roll will remain after sewing the tablecloths? So what the question, the information given in the question, a tailor used 2/5 of fabric, 2/5 to sew tablecloths, 3/4 of the remaining, 3/4 of the remaining, to sew pillow covers. What fraction of the whole fabric roll were used to were remained after sewing the tablecloths? Fabric roll will be the whole unit. Okay, out of the whole unit, 2/5 of the whole unit has been used. So 1 minus 2/5 of the fabric roll will give you the remaining fabric roll after sewing the tablecloths. That's the first step. So we have to make the denominators equal. When you're making the denominators equal, multiply it by 5. Multiply both by 5, the numerator and the denominator multiplied by 5. That means 5 minus 2 will give you 3. 3 over 5 will be your answer. That is the fraction of the whole fabric roll will remain after what fraction of the whole fabric roll will remain after sewing the tablecloths. What fraction of the whole fabric roll were used for pillow covers? So out of this, they are saying 3/4 of the remaining 3/4 of the remaining were used to sew pillow covers. So 3/4 of 3/5 So of turns to multiplication, hence we write it like this, 3/5, and nothing can be more simplified than this. Hence we straight away multiply 3 into 3, 9, 5 into 4, 20. 5 into 4, 20. That will be your answer for this, 9 over 20. After sewing the table, I think that's all I can simplify it. Yeah. Yes. After sewing the tablecloths and pillow covers, the length of the remaining fabric is 9 meters. After sewing the tablecloth and the pillow covers, the length of the remaining fabric, meters. Find the total length of the whole fabric roll. This is that model. Again, the direct proportion method. But here they are saying the length after sewing all these, the length of the remaining fabric is 9 meters. So what fraction of the whole fabric roll were used for pillow covers? Were 9 over 20. Yeah, 9 over 20 was used. And I'm correct, right? 3/4. Yeah, we had 3/4 of the remaining. Remaining was 3/5. Sorry about that. So So 9 over 20 was used for fabric rolls. Okay, what fraction of the whole fabric roll were used for pillow covers? 9 over 20. Taylor used 2/5 of the fabric roll to sew tablecloths. Out of the whole fabric roll, he has used 2/5. So they add the total amount he has used to sew both. Okay, after sewing tablecloths and pillow covers. Both. Make a denominator equal. That means multiply by 4. Multiply both by 4. So you will get here 2 into 4, 8. 8 over 20. 8 plus 9 will give you 17. 17 over 20 will be your total used. Okay, total used. That means remaining will be remaining after showing both of these. The remaining will be 1 minus 17. Out of the whole unit, 17 over 20 is being used. So 1 minus 7 over 20, make the denominators equal. 20 minus 17 will give you 3 over 20. So this 3 over 20, the length of the remaining fabric is 9 meters. This is the remaining fabric. This is 9 meters. If 3 over 20 is 19 meters, 1 over 20 is 9 divided by 3. 9 divided by 3, which will give you another 3, which will give you 3. Not another 3, 3. So find the whole length of the fabric roll, find the one unit, find the big unit of the fabric roll. That means multiply by 20. 3 into 20 will give you 60 meters. 1 over 20 over and 20 over 21. 20 over 21 and 3 times 20. That will give you 60 meters. If 3 meters of, okay, then moving on to that is the direct proportion method we have used up. And now we are moving on to the next part where they ask if 3 meters of cloth is needed to sew a tablecloth and half meter of cloth is needed to sew a pillow cover, find the number of tablecloths and number of pillow covers made using the above mentioned fabric roll. If 3 meters of cloth is needed to sew a tablecloth, if 3 meters of cloth is needed to sew a tablecloth, okay, and half meter of cloth is needed to sew a pillow cover, find the number of tablecloths and number of pillow covers made using the above method. So what they're asking is actually meter තුනක් යනවලු to sew a tablecloth. Okay, just remember that. And they are asking how find the number of tablecloths made. That means, yeah, we know that 2/5 of the fabric roll, 2/5 of the fabric roll is used to sew tablecloths. So we are taking 2/5 2/5 fabric roll is used. 2/5 that make it dealer in 3 meters of cloth is needed to sew one tablecloth. 3 meters is needed to okay, this is better. I found a way. That's a small thing. Yes. So the total length is 60 meters. Total length is 60 meters. Out of that 60 meters, they are saying to basically do a tablecloth. They need 3 meters out of that 60 meters. So how many are used? So out of 60 meters, let's see how many meters were used just to make the tablecloth. How many meters were used just to make the tablecloth? Was around 8 over 20. As I remember, it was around 8 over 20. So 8 over 20 will give you, now 1 over 20 is 3. 1 over, okay, we'll take the same thing. 1 over 20 is 3 meters. Okay, 1 over 20 is 3 meters. 1 over 20 is 3 meters. So if we want to find, again, then 8 over 20, here we found that 8 over 20 is the total length used for tablecloths. So 8 over 20 will be 1 over 23 meters long. 8 over 20 will be 3 into 8. 8 times 3, how much? Yes, so 24 meters. If 3 meters of, So out of the 60 meters, what we are doing is uh, the whole length. Okay, listen to me again. The whole length of the whole fabric cloth, whatever that is 60 meters. To make just for a tablecloth, for tablecloths, they said that 8 over 20. They said 2 over 5th, but we know that that is 8 over 20. 8 over 20 is used for tablecloth. If we find the total length used for tablecloths, can we find the number of clothes? Yes, we can. If we know the total, divide it and we can find the number. So that's what we did. We found 1 over 20. We know 1 over 20, the unit of one unit is 3 meters. So then 8 times of it will give you 24 meters. Out of 24 meters, 24 divided by 3 will give you, because 24 divided by 3 is because if 3 meters of cloth is needed for to sew tablecloth, the total divided by the single unit needed will give you the amount, will give you 8 tablecloths. Okay, so if you can do the other one, that would be great. It's the same method you can use. Well, this is the tablecloth, the number of total, like we divided the single unit that we got, then we got the number of tablecloths. Then we are moving on to the next one where it says the pillow covers. That is actually 9 over 20. 9 over 20. Yeah, how much? 9 over 20 means 3 times 9. That is 27. And 27 divided by half a meter. This is 27 meters. The whole length is 27 meters. So half a meter. 27 divided by half. Half is 0.5 or yeah, 0.5. That will be around that will be around 36 pillow covers. Yeah. No. Wait. 27 divided by 0.5. Yeah, correct. Right. 27 divided by 0.5. That will give you 54 pillow covers. Because half a meter of cloth is needed to sew a pillow cover. So they can make 54 pillow covers. So hope you guys got it. It's a bit trickier than last time, but if you have understood the question, it is very easy. It is not hard at all because we found the total length. What we did was in the third part of the whole question, we found the total length, and the total length is 60 meters. And they are saying 3 meters are needed to make one tablecloth and half a meter is needed to make one pillowcase. So what we did was we took the direct proportion method and found the length needed, total length needed to make the total length we got to make tablecloths. That was 24 meters. So out of 24 meters, if one tablecloth takes 3 meters, the number of tablecloths will be 8 because 24 divided by 3 will give you 8. And then we took the pillowcases. What happens was 9 over 20. 9 over 20 is the total used by us to make pillowcases. So out of those pillowcases, to make one pillowcase, they take half a meter, and the 27 meters is the total length. So 27 meters divided by half a meter will give you the amount of pillowcases we have produced. So 8 tablecloths and 54 pillowcases you have been used by this fabric roll, and there are remaining. We don't consider those. What we consider is what we have made, and that is the question. That was excellent question actually. And if you can do this, basically you're actually done with the exercises, honestly. So we'll move on to the hardest questions in the exercises now. This is the end of 2019 Western Province past paper questions. Now we'll move on to the last part of this whole session, the chapter, to revise the chapter again and to do some stuff. and we'll end it from here, from there. Yes, let's move on. Now, I will be sharing the screen, my normal screen. Yes, wait, wait. Okay, so you guys can see it, right? So what we did was, the first day, what we did was in fractions, we learned about the chocolate theory, where how it gets divided 1/10 in the form the 2/10 in the form of the chocolate piece slab the guy. Just check the previous episode. Please do check the previous episode, and then we are moving on to the next part where we said about the consist of oxygen and how oxygen is divided, the fractions. We did all this, and we learned about what is a proper fraction. We learned about what is a unit fraction. Unit fractions are 1/3s, 1/2s, while proper fractions are 2/6, where the numerator is lower than the denominator. And we learned the comparisons should that is really important, so you know that the know how it works. And then we learned what fractions is, and we then learned the addition and subtraction, where we learned the best theory, which is denominators should be equal. When it comes to addition and subtraction, it should be equal. And then we learned the multiplication and the division methods. Straight away when it's division, take the reciprocal, turn it upside down and multiply it straight away. That is the division method. Multiplication, you don't check denominators or whatever, just multiply the whole thing. Numerator by numerator, denominator by denominator. And then we learned the most interesting concept of the whole fractions lesson, the Bodmer's theory, where we are telling when it comes to a huge sum like this, which is shown in the screen, first start off with the brackets, then simplify the offs. Offs meaning another term for multiplication, turn it into multiplication, then simplify the divisions, then simplify the multiplications, then simplify the additions and subtractions. This is a more of a methodological process. So you won't get different answers, because different answers may occur if you do parts like, if you do addition first, there might be a different answer. So we all are following one method, so that will be easier for everybody. Then we did the review questions. We did half of it. We did a lot of it. We did the shaded region, I can remember. We did Sati's left home of bicycle. We did that. Then we came to the applications of fractions 3.1, where we learned about how fractions are moving and how this is happening. Ladies and gentlemen, please watch the first episode of this, first part of this fractions chapter 3. We did last week. Please check it out. The link is also mentioned in not just in our bio, not just here. I mean, not just in the caption. I will put the link in the caption too. Anyways, moving on, then we learned how we learned this direct proportion method, the inverse proportion, the direct proportion method, and we did a lot of sums from this. And then we didn't do 3.1 sums. We'll do 2 of an 8 sum, so it is easy for you guys, because we did the 2018 2019 papers. That means you are all good to go. So moving on to the 7th question of fractions 3.1, where it says black pepper and cloves have been cultivated in 7/8 of a plot of land. 7/8 of a plot of land. Black pepper has been cultivated in 450 meters, 400 square meters, while cloves have been cultivated in 1/4 of the land. Okay. Those are the most interesting parts I have underlined. So when you are also reading, if it's hard for you to understand, always underline. That is easier for you. What fraction of the land on which black pepper has been cultivated? So black pepper and cloves have been cultivated in 7/8 of a plot of land. Black pepper has cultivated in 450 meters, square meters, which clubs has been cultivated 1/4 of the land. 1/4 of the land. Okay. What fraction of land in which black pepper has been cultivated? Black pepper has been cultivated in 450 square meters. So 1/4 of the land is used by clubs. 7/8. 1/4 of the one. Yeah, so basically what they have asked is very I think it's make about that they have should mention 1/4 of the plot of land. Hari and mentioned this they say just land. I'm assuming it's the plot of land. So 1/4 of the plot of land now. 1/4 of plot of land, that is 7/8, will give you multiply. When you multiply this will give you 7/32. Am I right? 7/32. This is the plot of this is the fraction of land that has cultivated clubs. Okay, clubs clubs. So to cultivate black pepper, take the remaining will be the black pepper. The remaining 1/4 of 7/8 is this, or else you could have straight away or you could have taken 3/4 of that land. I mean, methaning on you can take that the remaining 3/4 will be straight away black pepper, or else you can take 7/32 and 1 minus 7/32 will give you the same answer, because 32 minus 7 will give you around 25/32. Or else if first method, the answer will be 3/4 of 7/8, which will be 3 into 7, 21. Wait. That can't be 3 into 7, 21 divided by, okay, sorry. 8 into 4, 32. This should give you 21 over 32. Where did we go wrong? Why is this wrong? Yeah, that's a very good question, because this is a bit wrong here. Something occurred. What is that wrong? So if we take 1/4 of 7/8, 1/4 of the land clubs are being plotted in, we cultivated in 1/4 of 7/8 will give you 7/32, right? And 3/4 of 8 will give you 32. Then from the whole thing, if we minus this cloud, I think this method is wrong because of some error. Let's move on with this. 1/4 of 7/8 will give you. I'm still interested in the fact that why is it wrong? Okay. It's something new. 3/4 of 7 over 8. Oh yeah. So anyways, let's stick to this method. I'm pretty sure this is the answer. 1/4 of 7 over 8 will give you the number of clubs cultivated on the plot of land, and 3/4 of that. Then this means 1/4 again difference. I thought you mean 1/4 of the land. So 1/4. 1/4 of 7 over 8 is this now. The remaining 1/4 of the remaining 1/4 of this 3/4 of 7 of 8 will give you the answer. 3/4 of 7 of 8 will give you the answer. The area of the whole land will be if 3/4 of 7 of 8. That means the fraction of land the black pepper is cultivated. This is 450 meters. They say 21 over 32. I think there is a small problem with this question. I just have to check this out. Just give me, because I'm not sure about that land. Meaning the fact that they haven't mentioned this properly, where it says it is cultivated in 1/4 of the land. What land? Like, is it? Are they talking about the land? The whole thing. Are they talking about 1/4 of the whole land or 1/4 of the plot of land they have cultivated? I'm not pretty sure about it. I have to do it again. So I'll do it and let you guys know. Please do ask me questions related to this. That please use us. Okay, I always tell please use us. Let's move on to the 8th question. A piece of wire has cut into 3 equal parts. One of the 3 parts was cut again into 4 equal parts. A piece of wire has cut into 3 equal parts. 3 equal parts. Okay, 1, 2, 3. One of the 3 parts was cut again into 4 equal parts. One of the 3 parts was cut again 4 equal parts. Okay, let's assume something like that. What fraction of the length of the whole piece of wire is the length of one small piece? So, what fraction of the length of the whole piece of wire is the length of one small piece? They ask you one small piece and me how much kill. So that is 1/4. This is 1/4 of 1/3. That means 1/4 එක තියෙන්නේ මේ 1/3 එක ඇතුළේ. එතකොට 1/4 of 1/3 තමයි answer කරනවා. 1/4 multiplied by 1/3, which will give you 1/12. What fraction of it? Illustrate about division of the wire and compare the answer you obtained in the so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Something like that. Because now this will where we should mention the fact that this can be also divided into 4 parts. We 4 parts of the academic again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There will be 12 parts. So 1/12 will be your answer. Perfect. We have done that question too. If a small piece of wire is 70 centimeters in length, find the length of the whole wire. If the small piece of wire is 70 centimeters in length, find the whole piece of wire. 1/12 is 70 centimeters long. Find the value of 12/12. That is what they're asking straight away. So 70 into 12, how much is 70? 12. 12 times 70. Multiply it very simply, we will get 840 centimeters. Okay, so that's it for that sum, and we move on to the further applications of fractions. Just a small overview, and in this session, because we have done the past paper questions very perfectly, we have done, and we did some questions here. And seventh question, yes, I will check on it because I'm also a student, I'm also an undergraduate. I also go wrong at places, but we are not coming. We are coming here prepared, but we are not. We haven't. We are also meeting these questions for the first time. Uh, so there can be errors like that. This is an error where I cannot understand the question properly, so I need to check on with it. So the eighth question, the last question of the whole exercise, which always people say is the hardest, we have done that. Moving on to the further applications of fractions. So they have said what our portion. So the further moving on is more like the fact that fractions spent on buying the books. This is what we did in our past paper questions. I know you guys went it fast, but this was what we did. So we'll move on to its last question and check whether it's hard. It's the same thing. We'll move on to the third question first, and then the fifth question too. Okay. Okay. It has been decided to allocate two-thirds of the floor area of a certain hall for classrooms, two-thirds of the remaining portion for or an office. The rest of the floor area, which is 200 meters, for the library. Okay, there are three parts of that. So, what fraction of the whole area has been allocated for the office? Office, two-thirds of the remaining portion for an office. So, it has been decided to allocate two-thirds of the floor area for a certain hall for classrooms. So two-thirds of the whole floor area. This is the from the whole. So out of two-thirds, one-third is remaining. So that means two-thirds of one-third. This two-third remain. Two-thirds of two-thirds of one-third will give you the answer for this. Actually, that is 2/9. What fraction of the whole area has been allocated for the library? What fraction of the whole area which is allocated for the library? So it has been we know now two-thirds from that and 2/9 for the office, and the rest of the floor area. So two-thirds plus 2/9. 2/9 is the fraction of the whole for the office, and for the classrooms two-thirds. What is the fraction allocated for the library? The question asks for the library. So rest of the floor area is which is 200 is what the library. So we should add these two. Find the total. Now we have a total, so we have to find the total. What is allocated for both the classroom and the office? Two-thirds plus 2/9. That will give you 4. This is 3 into 3. That means multiply this by the whole thing by 3. That will give you 6/9. 6 plus 2, 8/9. So 1/9 is the 8/9 will be allocated for this, and 1/9 is the remaining. This is your answer. This is your answer. This is your answer for this second question. Find the floor area of the whole. So 1/9 is how much? 1/9 is how much? 200 square meters. That means 9/9. The total will be 200 multiplied by 9. 2 into 9, 18. 1,800 square meters. Find separately the floor area allocated for classrooms and the office. Find separately the floor area allocated for classrooms and the office. Separate. Find separate. That means they're asking us to find this 6/9. 1/9 is 200. 6/9 will be 6 times 2. 6 times 2 is 12. 1,200 just for classrooms, and 2/9 will give you 2 over 9 will give you 400 for the office. This is the end of that whole question. We'll do the fifth one also. So Saroja read 1/3 of the book she borrowed from the library on the first day. On the second day, she was only able to read half of the remaining portion. On the third day, she finished the book by reading remaining 75 pages. How many pages were there in the total? Total in the book. 1/3 of a book she borrowed on the first day. 1/3 first day, and able to read half of the remaining portion. 1/3 on first day, half of 1/3 first day, day one, half of 2/3, because 2/3 is remaining, right? Half of 2/3 will give you 2 to 2 to cancel. Another 1/3 she has read. So from the total, she has now read 2/3. Okay, from the total, she has read 2/3. So on the third day, she finished the book by reading the remaining 75 pages. So the remaining 75 pages, which means 2/3 she has read, remaining is another 1/3. That 1/3 will give you 75 pages. 1/3 equals another 75 pages. Hence, the whole will be multiplied by 375 into 3, which will give you 15, 21, 75 into 3, 225. 225 pages. Always write the unit, and that's the end of that exercise. We did only few questions because we did the past paper questions, and you saw how they are very simple and they have a model to be followed. So please do follow those models. And with that, this chapter fractions is over. Hope you guys understood the further applications. They are very, very, you should read the question well. You should read the stuff given in the question, what they ask for. Like if it's a remaining portion, read that out. Those should be checked. And with that, it's time to end this chapter. Yeah, so fractions is over. The whole chapter is over. Thank you guys for listening. Yeah, wait. Let me stop sharing my screen. So we have done everything related to fractions. Now you have a sound knowledge on fraction. I'm pretty sure you have sound knowledge, but if you don't have anything, like if you have any questions with regard to this chapter, you can always ask us in the comment section. Please go out and type us and please go and type all the questions you guys need, you guys have, and please let us know whatever it is. And also please do this favor for me. It would really mean the world to me if you can share this with somebody who needs it very well, like you. Like share it with the person who you think would benefit from this. Please do, because that means a lot to us as the Rotary Club of NSDM. It's our duty to help you guys, and that's what we are going to do with Road to A Plus initiative. Hope all the sessions are really going well, because now we are adding new sessions, new subjects to with new people, and we are trying to expand, and we all are doing a great job. So please, let's have some fun. I mean, with this Road to A Plus initiative, we are trying to give you all the best. So we are trying to give you all the best materials, all the best knowledge, and all what we know we are going to tell you. So with that, it's time to end. Thank you so much for listening to me. I'm Denominator from Surya, Rotaract Denominator from Surya. This is grade 10 mathematics, and we just finished fractions lesson, chapter 3 of your grade 10 mathematics. And thank you so much for listening. So as the PR director of Rotaract Club of NSDM, let me say this one more time. Please go out, go down and click on the like button, subscribe if you haven't subscribed, and please share this video. Thank you so much for listening. I'm Jonathan Surya. Thank you so much.